Okay, I'm going to try one last example here for section 4.9. This is number 20 from the textbook, and this is going to be a system of three equations in three variables. Three variables, x, y, and z. And so first thing we're going to do is remember use D notation here. So this first equation just becomes dx plus x minus z equals 0, or if you factor out the x, d plus 1 of x minus z equals 0. All right, the second equation becomes, let's see, dy plus y minus z equals 0, or d plus 1 of y minus z equals 0. And finally, we get dz plus x minus y equals 0, or if I put the x minus y in front, get x minus y plus dz equals 0. And sorry, it's a little sloppy, so let me rewrite everything over here. So the first equation we'll call d plus 1x minus z equals 0. The second equation, very similar, d plus 1 of y minus z equals 0. And finally, the third equation is x minus y plus dz equals 0. So, all right, so let's go back to elimination. What do we want to eliminate? So I already tried this with trying to eliminate z, and it didn't work very well. It might work out for you, but what I'm going to do is actually try to eliminate the y. So I'm going to expand this out. So the second equation here becomes dy plus y minus z equals 0. And then the third equation is x minus y plus, dz equals 0. And by adding these two equations, you're going to eliminate y here. You get x plus dy minus z plus dz equals 0. Well, okay, that eliminated the y. It did not eliminate dy. So what can we do there to eliminate dy? So, right, here we just have xz and dz, right? And here we have x and y and dz. So the thing I'm going to do is just take d of this, right? I get dx minus dy plus d dz, which is d squared z, equals d of 0 is 0, right? And so now, when I add that to, this equation here, I eliminate the dy's as well. Plus d squared z equals 0. So now when we add these, I get x plus dx, or d plus 1 of x. These cancel, and then I get a bunch of z's here. I get d squared z plus dz minus 1 of z equals 0. Okay, right? So we eliminated not just the y's, but the dy's as well. And this is a d here. All right, so what's next? Well, somehow we want to eliminate either x or z here. Well, we know what z is, right? From the first equation, z is really just d plus 1 of x, right? So plug that in here, and what do we get? We get d plus 1 x plus, well, d squared plus d minus 1 of d plus 1 of x equals 0. So you might think of multiplying all this out, but I'm looking at the d plus 1x here and just factoring that out. So you get d squared plus d minus 1 of d plus 1 of x. Oh, wait a minute. Yeah, we're factoring it out, right? So we get this, and then we get plus 1 here. So there's a plus 1 right here. Oh, I messed that up. So yes, negative 1 and then plus 1. So 1 minus 1. Maybe I should just rewrite this, right? Minus 1 plus 1. Right. And then d plus 1 x. So, okay, so this is 0 here. We get d squared. Actually, d squared plus d is just d of d plus 1 of d plus 1 of x, which is really just d of d plus 1 squared of x. And that still equals 0, right? Okay, so now how do we solve this equation? Well, one way is to expand this all out. If you expand it all out, you just get x triple prime plus 2x double prime plus x prime equals 0, in which case the auxiliary equation here would be m cubed plus 2m squared plus m equals 0. However, you'll notice that it's going to look very much like this. It's going to be m times m plus 1 squared equals 0. Oops, sorry, equals 0. Right. So there's two solutions to the auxiliary equation, right? There's m equals 0, and there's m is equal to negative 1, which is a double root, right? So m equals 0 just gives us, oops, not y. We're solving for x here, right? It's not working. Well, let me just cross it out. Okay, so x1 is equal to c1 e to the 0, which is just c1. And x2 is going to be c2 e to the negative 1 times x. Oh, sorry, not x, but t here, right? And then x3 is going to be c3 t e to the negative t, right? We need a linearly independent combination here, right? So our x of t, putting this all together, try that again, x of t is going to be c1 plus, and then factoring out the e to the negative t, we get c2 plus c3x times e to the negative t. Okay, so that's a good start. We found the solution for x of t, but now what about y and z? Well, we're in luck here, right? We can get z pretty quickly. Z is just d plus 1 of x, and this is x. So what's dx? Dx, of course, is just x prime, and the derivative of this is going to be 0, and then, though it's not as simple as I thought, there's going to be a product rule here. So let me write x prime as, so first times the derivative of the second plus second times the derivative of the first. So negative c2 plus c3x. That's not an x, right? That's a t. Oops. T here. T. So, yes, times e to the negative t. All right, plus second times the derivative of the first. The derivative of the first is just c3 times the seconds. So let's see what we get, right? We get negative c2 e to the negative t minus c3t e to the negative t plus c3 e to the negative t. And I know that's sloppy, but I'm going to rewrite it a little bit neater here. So we factor out the e to the negative t, and we get, let's see, c3, I want to well, okay, minus c2 minus c3t. Okay, so that's x prime, or dx. So what's d plus 1 of x? Right, and this will be our z. So it's just this plus x, and here's x. So when you add these up, you know what? I'm just going to split all these up again. We get c3 e to the negative t minus c2 e to the negative t minus c3 t e to the negative t. So that's the d part, dx, and then plus x. So plus c1 plus c2 e to the negative t plus c3 t t e to the negative t. And okay, so let's see, we have, so we have a negative c2 e to the negative t and a positive c2 e to the negative t. So those cancel, that's just 0. And we have, I think, the same thing here, negative c3t e to the negative t plus c3t e to the negative t. So that's also 0. And so really we're just left with c1 plus c3 e to the negative t. So there's our z of t. Right? So let's put the c1 first, c1 plus c3 e to the negative t. And that's the z function as a function of t. Okay, so all that's left is to find y. And, well, I guess we can use either the first or the second one. Let's use the third one, sorry, the second or third one. The third one is y equals x plus dz. Okay, so we already have z. I think we can get dz pretty easily because dz is just the derivative of z, which is 0, and then minus c3 e to the negative t. So let's see, where's x? X is down here somewhere, so just add x plus dz. So x was c1 plus c2 e to the negative t plus c3t e to the negative t minus, plus dz, which is this, minus c3 e to the negative t. And that's your y of t. I guess we can write this, let's see, what should we do? C1 and then pull out the e to the negative t here. So c2 plus c3, and I think I'm going to do 1 minus t here, all times e to the negative t. So I guess that's it. Yeah. So these three, x, y, and z, comprise the solution to this system of equations. I have a slightly different answer here. I actually, for y of t, I have c1 plus c2 minus c3. Did I miss a minus sign here somewhere? This is c2 plus c3t, right? That's not a minus. Well, then it should be c1 plus c2 plus c3 times e to the negative t, and then minus c3t e to the negative t. Okay, slightly different answer than what I had. But let's see, y is equal to, yes, x plus dz. So here's x, and then dz. Did I calculate d? Oh yeah, no, I'm sorry. Yeah, here's x. Dz is just negative c3 e to the negative t. Oh, right. So there should be a minus sign here. Okay. Hang on. This should be a minus sign here. Yeah, because then this becomes a plus. Minus a negative becomes a plus. So that's minus. Okay. So I think that's the only mistake here. And then this should be a minus sign here. And then this should be a plus sign, I think. All right. So I wish there was an easy way to fix that, but that's the best I can do. All right. Either way, look, I'm not going to be picky here. Either way is fine. Let's not worry about all these negative signs here. So that solves this system of equations. And again, this was obviously a more difficult one, being a system of 3 equations and 3 variables, but it's just going through the process here and eliminating variables one by one. And so I hope that helps. But yes, very confusing. All right, that's that.